Today we're working on 11.6 and we are factoring quadratics. So this one is the easy type. The leading coefficient is a 1. So we factor two numbers that multiply to be -12, add to be 4. That would be x plus 6 and x minus 2. And since it says factor, we can stop right there. We don't need to go any farther. Okay. Here the leading coefficient is not a 1, and I can't pull it out in any nice fashion. So I draw the box. I put in 3y squared and -5. Multiply those together. -15y squared. I factor 15. 1 and 15, 2 doesn't work. 3 and 5, 4 doesn't work. And then this sign is negative, which tells me the factors have opposite signs. And this sign is negative, which means the bigger of the two is negative. So when these numbers fight it out, the big side is going to win, and the big side is negative. Will one of those give me a -2? Yes. -5y and 3y. What does the top row have in common? A y. If I pull out a y, then I get 3y minus 5. And then I pull a 3y out of here, and I just get a 1. So my and double check, does this times this equal that? Yes. So my factors are y plus 1 and 3y minus 5. All right. How is this going to work? You could use the box. So I put in x squared and 18y squared. Multiply those together, and I get 18x squared y squared. And those factors would be 1 and 18, 2 and 9, 3 and 6, 4 and 5 don't work. And this is a negative, which means my signs are opposite. And this is a positive, which means the bigger one is plus. Will one of those give me a 3? Yes. -3, but it has to be xy and 6xy. What does the top row share? An x. If I pull out an x, I'm left with x minus 3y. And in the first column, I pull out an x and I get 6y. So my factors are x minus 3y and 6x plus y. Now hopefully you can look at this original and say, if it was x squared plus 3x minus 18, that would factor into x. Oh, I totally got that wrong. Sorry, minus 6y. I can factor that into x minus 6 and x plus 3. And then notice I just need y's. So if I put a y there and a y there, it will work. Okay. Stick in the 10z squared and the 2. That makes 20z squared. Are there factors of 20 that add to be 21? That would be 1 and 20. So 1z and 20z. Pull out a z, and I get 10z plus 1. Pull out a 10z, and I get z plus 2. So my factors are 10z plus 1 and z plus 2. Okay. Here it wants me to factor completely, but notice I can pull out a 4. So I'm going to pull out a 4, and that will give me x squared plus minus 11x and 14. Let me double check that. 18. Okay. So that is 4 times x minus 9 and x minus 2. And that would be the factored form. All right. Anytime you have a negative out front, I recommend that you pull that out of the leading coefficient and all the other terms. So I'd like to pull out a -3, but that would be messy. So we just pull out a negative, and we have 3u squared plus u minus 14. And then we draw the box. 3u squared, negative 14, times those together, 28, 52, negative. Factors of 52 that add to be 1 would be 7u and negative 6u. So we pull out a u, and we get 3u plus 7. We pull out a 3u, and we get u minus 2. So my factors are negative u minus 2 and 3u plus 7. We are definitely not doing this problem. I will delete it. All right. Get to work.